Yes, we get a chance to write the exponential equation based off of a pattern. And when we do this, we're going to really focus in on that gap between that 2 and that 64. It is easier if we just use the 64 and the 128, but we're going to use that as a reference for that big gap between 2 and 64 and 128. Okay. All right. So the first thing we're going to do is we're going to look at the rate. And let's go ahead and find that between the 64 and the 128. And so when we find the exponential rate, we can just identify, well, 64 times 2 is 128. But if you didn't know that, I might say 128 divided by 64. That is going to give us the rate, which is a value of 2. And what that means is we're multiplying by 2 every single time. Now, let's go ahead and look at that 2 and the 64, because what you're going to notice is there is a gigantic gap in data between those two. But if we use the same idea that we used over here, we would just take, well, let's take 64 and let's divide it by 2. And when we do that, we would say, well, 32. Well, that doesn't at all line up with that 2 over there, but let's see how that kind of lines up. Well, if I was to do the process with this value of 2, we would say, well, we would multiply by our rate of 2. We'd multiply by our rate of 2. We'd multiply by our rate of 2. We'd continue to do this all the way until we got to that 64. And what would end up happening is we would multiply the rate 5 times, 1, 2, 3, 4, 5, or we would say we've done that r to the 5th power. And that r to the 5th power is this gap of 32. Now, when we solve this problem, what I want to end up with is r to the 1st power. Well, how do I do that? Well, I multiply with 5 by 1 over 5, or I use the reciprocal. And when that happens, I'm going to do that to one side. I'm going to do it to the other side. So I'm going to put 32 to the 1/5 power into desmos, and we're going to look at that. 32 to the 1/5 power, and check it out, r becomes 2, just like we had originally thought. Now we can go ahead and fill out our data points. I know that we're multiplying by 2 in this direction, so that's 4, and we keep just going 8, 16. We could also go backwards. Instead of multiplying by 2, we could take the 64 and divide it by 2 and get 32, and we can continue to fill this out all the way until we're finished. So now we have the rate. Let's go ahead and set up a table, and we're going to build our equation and make sure it goes through all of these points. So let's say the first point is 2, the second point is 4, the third point is, the third point is 8, the fourth point is 16, and we just keep putting these points in until we're all done, 32 and so forth. And we get the 6th point to be 64. And I'm going to leave it right there because if it goes through those points, we're going to be verified. Now, what we did was we counted this to be our first point, that 2 to be our first point, our second point, third, fourth, fifth, sixth, and so forth. When we write an exponential equation, y equals a b to the x, a is the initial value when x is equal to 0, or it's the 0th term. And this is our rate, and we've already found that. So when we write this equation, we have to say, wait, we don't have the 0th term, we have the first term. So we actually have to go backwards to figure that out. If we're multiplying in this direction, that means we'd have to be dividing in the other direction. So let's take 2, we divide it by 2, and that gives us 1. Now we can write our exponential equation, which should be y equals 1 times 2 to the x. And let's plug that in. Let's see if it goes through our points. And if it does, it verifies that we've done this correct. So y equals 1 times 2 to the x power. Goes through all of our points, so everything's verified. And that's how we deal with gaps in data.